Hello everyone, my name is Krunoslav Plecko, and today I will talk about visualizing YouTube video context, essentially about NLP pipelines. So the project that we did is the project for University College Dublin. It was the part of the master's final project. And the main topic that we had for this project was data for social good. So we needed to come up with some solution which will map with this team. So basically, we started with creating the team. We needed 6 students in the team. Basically, we started with the interviews and finding the best people for the project. After we got a team, we started to brainstorm project ideas, eventually which led to project proposal and approval. The next step was to define the vision and MVP of this project. Also, we needed to select technologies and project management stack. Next step, develop, iterate, and evaluate the solution. So we named the team Abracadabra. So it's a magic time. Basically, name of the project is Yousights. So the best way how I can introduce you the problem that we had, I prepared one small video for you.
That's what I thought. Yeah.
Thanks, John.
Thank you.
I have an interview tomorrow, so I'm looking for the videos for some technical problems. But you know, how do I know which one is the best for you now? Documenting.
Yeah, but it takes ages.
Yeah.
Have you ever heard of Yousights? Yeah, it's this cool new website where it visualizes the content of YouTube videos for you and it makes the problem of finding YouTube videos quickly much easier.
Really?
Check it out.
Oh my God,
Yousights!
Okay, now we made a team, and you saw the problem. So basically, it can be really time-consuming to find the videos online, and we tried to actually simplify that process and make it easier for the users. So basically, we had 2 users groups. So we can see here 2 students, Tom and Jerry. So one of the users is actually social learner, Tom, and he prefers meetups and social events. Jerry, for example, he's more individual learner. So he preferred some YouTube videos and slow-paced tutorials, for example. So what was the vision of this project? So we wanted to refine time-consuming YouTube searches for skill enhancement. How to do that? Basically, filter out videos by educational content, help users to confidently identify relevant videos, and navigate directly to the most useful part of the video. So what was the data stack that we used in this project? As I mentioned before, we had 2 user groups. We had the individual learner and social learner. So to target individual learners, we wanted to extract YouTube video transcript. So basically, you're watching the video, and we took the transcript from that video. Also the comment and some statistical data. What challenges we had with YouTube? There was no transcript for some videos. Also, we had performance challenges. How do you take 200 videos and display results in just 3 seconds to end user? And also with APIs, there's a rate limit. You can have just 10K per day. From opposite side, we had social learners. So we took the data from Eventbrite, Meetup, and actually we mapped this data on the maps, Google Maps. Also, we had similar issues here, API rate per day, how to filter relevant events and show them on the map. So data collection. So we had 2 types of search. So one search is live search. So that's the case when we actually present directly data to the user. This is events, meetups, and Google Maps. Why? Because all of these events, they change constantly per day. YouTube, if you have top video on the top that day, it won't change every hour. So for that reason, we cached that results, which saved us some performance. And we have scheduled process. We had scheduled process which was scheduling every day and grabbing these videos in MongoDB. Also, the second part of the project was the books. So we wanted to map these videos with the books, and I'll talk a little bit later about that. So we wanted to find the best and highly rated book related, for example, to the Python. This is one of the examples of introduction to Python. It's really highly rated on Amazon. The challenge. So what was the challenge here in this project? Okay, so the first challenge, how you display the context of YouTube video. There's so many words, there's so many non-related words, like philosophy in this case. How do you remove that words without actually manually doing that? The second challenge, and this was the key algorithm of our project, was actually creating algorithm which will sort the videos based on knowledge. So we came up with the idea to take the knowledge from the book, take the highest rated book from internet, and find overlapping with video context and create algorithm to sort by that. Also, we wanted to help users with the comments, because usually when you go to YouTube video, there's so many comments. It's really hard to find the most critical and most positive comments. It's so time-consuming task. So for example here, we can see really positive comment. Somebody wanted to donate us some money. And we can see some other comments which are complaining about slowness of the website. So we focus it on two key parts. We focus it on the most positive comments and the most negative comments here. And one of the most challenging tasks. So as you know from YouTube videos, not every video have table of content. And so basically we wanted to compute table of content and enable the user to jump to the part of the video which is actually relevant to the user. So this is an incredibly challenging task. Challenge accepted. So what technology stack we used here? Normally, Python. We love Python. So how we started with this? We looked for the project requirements. What do we need actually for this project? So the project was really fast-paced. We had just 2 months to actually complete this project. Do research, state-of-the-art, chose the technology stack, create end-to-end solution, deploy, and finish the MVP. So we also look for team competencies. What kind of competencies we had in the team? So most of us, during the college time, we learned Python. And it was an easy choice, basically, here. Also, something that is really straightforward to implement. We also love open source technology, and the key focus was automation. Why Python? It's easy to learn. It's flexible and open source. There's a huge ecosystem and community around the Python, and it's really amazing choice for machine learning. Basically, it's great for productivity and speed, especially in this kind of super fast-paced research projects. Just to show you a glimpse what kind of libraries we use it here, there is some standard stack for data science like NLTK, Pandas, GenSim, and so on. We also used PyMongo. We did our custom logging. Also, we use quite a lot of threading. And in this case, we use Flask REST Plus because it's super slim and straightforward to implement. And we wanted to have automated Swagger documentation directly from the code to minimize the time for that. Our code is completely PEP8 compliant. So for that case, we use FLEC8 together with Travis. And we spent some time with the documentation. So we chose Google Docs strings. Here's the high-level overview for NLP pipeline. So you can see from the left side, we had YouTube videos, transcripts, also events. The first step of this processing was data preprocessing and cleaning. There was so much data and so much noise there, so we needed to clean that data. The second part is machine learning, NLP, extracting sentiment, calculating frequency of the word, and eventually visualizing the data. So let me give you a little bit more detailed overview. So you can see two data sources. We have YouTube videos and we have books. So from YouTube videos, we took comments and transcript. From books, we looked how to actually extract the knowledge from the book. It's a really hard task. So we realized that index have quite a lot of information about Python and everything. And we took the words from index and context. Also, we processed that words. We took the keyword extraction, cleaning the indexes, and so on. So we created the corpus from one side. From opposite side, we also had keywords extraction, word frequency, entity extraction, and sentiment. So basically, I'll show you later the end result. We have the word cloud. To minimize the noise in the word cloud, non-relevant words, we compared video context with the book. And this is the way how we actually created the corpus of the words for word cloud. The challenges that we had. One of the biggest challenges was single repository for all the microservices. It was really, really challenging. You know, how do we develop, how do we deploy with just one single repository? So just to give you an idea, in just 2 months, we had 500 deployments in 2 cloud environments. So for Platform as a Service, we chose IBM. They sponsored that environment. And Google gave us some sponsorship for GPU. When we started, we used just PaaS. And you know, for start, it was OK. Later on, it was quite slow. So we needed something more manageable. So basically, we chose the GPU in Google Cloud. Also, we use the common cloud database. In this case was Mongo. They also sponsor us. Let me show you the architecture. So from the left side, you can see data sources, YouTube, Eventbrite, and Meetup. So we fetch this data from the internet. And the first microservice is for YouTube. So we use that microservice to pre-process the data. And it was a really good choice. Actually, we used the microservices to split the ownership in a team. And it was quite straightforward to develop. The second microservice for events, to process the event data. And the core of this project is Analytics AI microservice. We use that microservice to calculate sentiment, similarity, word frequency, table of content, and entities. Also, we save that data to Mongo to provide live search and cached results. And we developed in Python some custom monitoring microservices. So this is the landing page. So basically, we wanted to provide a really simple page to users to search educational content. And let me show the results. So here you can see the sorting. The first video is super relevant to Python. The second video, not so much. If you love the snakes, maybe. So basically, you can see in the word cloud, there is no philosophy, there is no words which are non-related to Python. So all of these words are matched with the Python book to deliver the result. So basically, if you don't know about word cloud, so the word which is the largest word there is the most frequent word in that video. Also, this is showing you sorting by relevance. So basically, all the relevant videos with the Python, they're on the top. All non-relevant videos, they're on the bottom. Here is an example of the sorting. And if you use the search term Python, we showed all of the events in the city which are related to Python. And we have a really nice example here with the PyCon. I think this was taken like 2 months ago. And we realized that there's a significant help in video selection. So imagine you're searching for Python video. And maybe you use Mac. And for some reason, maybe you use JetBrains. So basically, you want video which will help you to use your tools and teach you something. So this is the example of keyword extraction. So imagine you have all of the list of videos, you click on the video, and the first thing that you get is summarized data. So you can really easily realize, okay, this video is talking about Python. Python is the largest word on the word cloud. There's something about functions and classes. Probably it's some beginner video. Okay, it's using Mac. I use Mac. Cool. And then best and most critical comments. So you can really easily get the feeling, is that video right for you? So what issues we had? Like I mentioned before, we had so much issues with APIs because we use free tiers. Performance issue. How do you calculate all of these things to satisfy user and display all of this data just in 5 seconds? And table of content computation. So what would be the future extension of this project? We could support multiple languages. As you see here, we have specific website. So it's really hard to get your users to go to your website. So this could be much better if we have extension. So imagine you have Chrome extension, and which could show you all of these results while you're searching on YouTube. Also colorblind friendly application and some more topics. In this case, we just targeted programming and educational videos. Also, one of the most important part of this project was actually evaluation. And we had lots of challenges here. One of the challenges was time constraints. We had just 2 months. How do you build all of this, automate, research, and perform some evaluation? And the second problem, it was actually the participant bias. We had users, just our teammates, students. So basically, it's a small group, and they already know our project, so they have bias toward our project. We came up with a few evaluation hypotheses. The first one, how relevant are videos actually to the search term for the given topic? The second one, how confident is the user with our visualization that is the right video? And the third one, what is the user satisfaction on the end? We got really mixed results. So visualization, they actually help user to get confidence to choose the video. And there was no significant time delay. So basically, if you're searching the videos on YouTube and with our tool, there is not much delay. You won't spend much more time for that. The interesting part, we didn't got significant improvement with our searching algorithm. And I think that was the base because we didn't explain enough how our algorithm actually works. It was not straightforward for the user to understand why we are sorting with the book. And we gained a significant help on the second stage of the video, when actually a user can see entities in the video and the comments of the video to choose the right video. So here you can see the charts. So we compared YouTube and Yousights. In some cases, we won. In some cases, it was YouTube. But overall, the satisfaction was quite OK. And we did one specific API in Python to track the users. By the way, without user data, we are GDPR compliant completely. So we realized that users mostly search for Python, Java, Django, and sometimes they're hungry and they search for food. And they love, if you see on the bottom, they love Indian food. And to evaluate the results, we implemented these emojis. And you can see on these emojis that mostly they like our website. So what are the potential improvements based on an evaluation that we did? We could have relevance filters for search results, display the channel name, because if you know who is the author of that video, it gives you more confidence in that video. We could reduce the size of visualization. When you have 4 hours video, and when you squeeze all of that words in the word cloud, it can be a little bit messy. And also improve instructions how to use the application. OK, here's the team. So we used ZenHub, Kanban, Agile. We had 1-week sprints. We did lots of metrics and velocity, daily scrums at 10 a.m. in the morning. Some of us actually work full-time. Part of the team was full-time students. So that was really a huge challenge. How do we work together? We had Saturday retrospectives. We worked for the weekends. We did lots of learning online. We opened some team accounts on Udemy. Lots of knowledge sharing, pair programming. We also love Nintendo and some food events. So what lessons we learned from this project? Basically, if you have processes and tools and ownership, equal no chaos. Everything is straightforward. Do your evaluation early. Get the feedback. Testing is really important. So we did some unit testing, but unfortunately, toward the end of the project. I wish we did this earlier. Teamwork is also really important. Python is really fun and sometimes really slow. OK, here's the team. We are really proud on this project. Final result is we got A grade. Thank you so much.